class 10ers. Now today we'll start with a new chapter, chapter 4, Refraction of Light. Now before we start with this chapter, in class 9 you have read about the term reflection. There is a difference in reflection and refraction of light. Reflection of light means bouncing back of light into the same medium, but refraction of light is the bending of light when it passes from one medium to another medium. So now the medium means the substance in which the light travels or try to travel. The substance in which the light travels, they are known as the medium. So there are two medium. One is a rarer medium, okay, and other one is the denser medium. Number one is the rarer medium, and other one is the number two is the denser medium. Okay, and rarer medium, air is considered as a rarer medium. Air is considered as a rarer medium. Whereas denser medium is glass and water, alcohol, all these are the denser medium. Okay, so rarer medium and denser medium. Medium means through which the light travels, they are known as the medium, and there are the two medium, one is a rarer medium and other one is a denser medium. Air is considered as a rarer medium, and water, glass, alcohol is considered as, even a diamond, okay, etc. These are the denser medium. And rarer medium is only air. Air is only the rarer medium. So when we discuss about the term reflection, so in reflection of light, when the ray of light passes, okay, from that means when I consider this is a reflecting surface, let us consider as a mirror, okay, and I will draw a straight line here which is perpendicular to the reflecting surface. This is known as the normal here, and O, and that is the normal, and the ray of light is coming from air, that means from rarer medium. Let us consider this as air. Okay, now AO is the incident ray. You know that in class 9 we have read this. AO is the incident ray, the ray of light which is coming from the source. Okay, AO is the incident ray. When it falls on the reflecting surface, the ray of light will go back to the same medium. The ray of light will go back to the same medium. That means whichever the medium the ray of light is coming, after striking the reflecting surface, let us consider this as M1 and M2 as a reflecting surface, and this is a plane mirror. The ray of light falls on the plane mirror, that is the reflecting surface, M1 and M2, and this ray of light will go back to the same medium. Wherever the ray of light is coming into the same medium, the ray of light will go. Okay, so which we call it as a bouncing back of light, that is the reflection. So in a reflection of light, the ray of light, it falls on the reflecting surface and goes back to the same medium. Okay, likewise, you take a ball. Okay, a ball is on your hand. You just bounce the ball on the ground, on the floor. The ball, it strikes the ground and it comes back to your hand. Likewise, like that. Okay, in reflection also the same thing happens here. The ray of light coming from the medium, okay, let us consider air, when it falls on the reflecting surface, and it will bounce back to the same medium. Whichever the medium it has come, it will go to the same medium. So that is reflection. But in case of a refraction of light, okay, and in refraction of light, when the ray of light passes from one medium to another medium, let us consider this medium as air. Okay, and air, as you know, considered as a rarer medium. Glass, water, alcohol, diamond, etc. All these are the denser medium. So this ray of light, when it passes from rarer medium towards the denser medium. Okay, so PQ is the separating the two media. PQ is the line which I have drawn here. Okay, so this line PQ have separated the two media, that is air and the glass. Air is considered as a rarer medium, glass is considered as a denser medium. So now the ray of light passes from air to glass. That means the ray of light has to pass from air to glass. So when the ray of light falls on this separating medium here, okay, partially the light will be reflected and partially the light will be refracted. Okay, the light will be refracted. So when the light will be refracted here, okay, the light will travel towards the glass. That means from here the light travels towards the glass. So when the ray of light travels towards the glass, the bending of light takes place. So this bending of light is known as the refraction of light. So therefore, when we come to the definition of refraction of light, it means that the bending of light, when the light travels from one transparent medium to another transparent medium, is known as the refraction of light. So in the refraction of light, always the bending of light takes place. And this bending of light takes place because of the difference in the speed of light in a different medium. Okay, speed of the light in a different medium. So the speed of the light in a two different medium, that is rarer and denser medium, are different. The speed of the light in rarer medium, that is in air, is 3 into 10 to the power of 8 meter per second. You know that? Okay, in class 9 also we have read that the speed of the light in air is 3 to 10 to the power 8 meter per second. When we come to the denser medium, that is in glass as well as in water. In a glass, the speed of the light is 2 into 10 to the power of 8 meter per second, and in water 2.25 into 10 to the power of 8 meter per second. So that means there is a difference in the speed of the light in a two different medium. So due to that difference in the speed of the light in two different medium, the refraction of light takes place. That means the bending of light takes place. Okay? So from this figure, you can see here AO is considered as the incident ray. OC is the reflected ray. This is the reflected ray, since the ray of light is going towards the same medium. Okay, since it is coming from A to O and again from O to C, going back to the same medium. This is the reflected ray, and OB is the refracted ray. Okay, since the bending of light is taking place here, OB is the refracted ray. Then NO and dash is a normal. They are considered as a normal. Okay, then and the angle made by the incident ray with the normal. AO is the incident ray. The angle made by the incident ray with the normal is known as the angle of incidence. So therefore, angle AON is the angle of incidence. Again, angle CON is the angle of reflection. This is the angle of reflection. Angle BON dash is the angle of refraction, which is denoted as small letter r. Okay, so angle of incidence is small letter I, angle of refraction is small letter r. Okay, and NON dash is the normal. PQ is the surface separating the two medium, that is air and glass. And again, the next point, light always travels in a straight line. You know that? And the light in which they travel in a straight line, we call it as a rectilinear propagation of light. But this light travels in a straight line when the light travels in the same medium. When the light travels in same medium, they always travels in a straight line. Okay? Because when the light travels in the same medium, the density in that medium will remain same. So when the densities are same, the light travels always in a straight line. There will be no bending of light. Okay, there will be no bending of light. The light travels in a straight line. But when the light travels from one surface or one transparent medium to another transparent medium. Transparent means the substance to which the light can travel. They are known as the transparent medium. Okay, transparent means the substance through which the light travels, they are known as the transparent medium. So therefore, when the ray of light travels from one transparent medium to another transparent medium, in that case, the bending of light takes place. Because the densities in a two different medium, in two transparent medium will be different. Okay, the densities in air as well as in the density in the glass and water will be different. Similarly, the speed of the light will also be different. So due to the difference in the densities and difference in the speed of the light, the refraction of light takes place. Okay, refraction of light takes place due to the speed of the light in a two different medium. So now the speed of the light in air and glass are different. So due to that, refraction takes place. So what happens is that when the ray of light passes from air to glass or radiant medium towards the denser medium. When the ray of light passes from the radiant medium towards the denser medium, the ray of light will bend towards the normal. Remember that? When the ray of light passes from radiant medium to denser medium, the ray of light will bend closer to the normal. So when it becomes closer to the normal, the angle of refraction will become less. Okay? The first condition is there. When the ray of light passes from radiant medium towards the denser medium, that is from air to glass, the bending of light, the light will bend closer to the normal. So when this refracted ray or when this light will bend closer to the normal, in that case, angle of refraction will become less. So in that case, angle of incidence is greater than angle of refraction. So this condition will happen or takes place when the ray of light passes from radiant medium towards the denser medium. Second point. When the ray of light passes from a denser medium towards the radiant medium. Okay. Next point. When the ray of light passes from denser medium towards the radiant medium. That means from glass or water to air. In that case, the bending of light the light will bend away from the normal. Okay. The ray of light, the bending of light will take away from the normal. So that means when the bending of light takes away from the normal, in that case, the angle of refraction will be greater than the angle of incidence. So the second condition is there, angle of incidence will become less than angle of refraction. So this will happen when the ray of light passes from the denser medium to radiant medium. So when the ray of light passes from denser medium towards the radiant medium, the bending of light takes place away from the normal. So when the bending of light takes place away from the normal, in that case, the angle of refraction will become more than the angle of incidence. Third condition. When the ray of light falls towards the normal, in that case, when the ray of light, when it falls, instead of forming an angle, when the ray of light falls on the normal, okay, there will be no bending of light, no refraction takes place. So in that case, angle of incidence will become equals to angle of refraction. That means no refraction of light takes place, no bending of light takes place. So this condition will appear when the ray of light falls directly on the normal. Instead of forming on this side, on this angle, okay, when the ray of light falls on the normal, okay, there will be no bending of light. So in that case, the angle of incidence is equals to angle of refraction. So these are the conditions, okay, when the angle of refraction will become less, angle of incidence will become more. When the angle of incidence become less, angle of refraction will become more. When the angle of incidence and refraction becomes equal, so these are the conditions. So this shows that the ray of light, when it passes from radiant medium towards the denser medium or from denser medium towards the radiant medium, all these conditions will take place. Now the next point will come to the laws of refraction. Now there are two laws. The first law states that, the first law of refraction states that the incident ray, the refracted ray and the normal all lie at the point of incidence. Okay, that is the first law. The incident ray, the refracted ray and the normal all lie at the point of incidence. That is the first law. Second law states that the sign of angle of incidence, that means the sign of SIN is sign of angle of incidence to the sign of angle of refraction. The sign of angle of incidence to the sign of angle of refraction is constant. The second law says that the ratio of the sign of angle of incidence to the sign of angle of refraction is constant for a period of media. Okay, and this second law was discovered experimentally by Willibald Snell in 1621. Willibald Snell, he was a scientist, okay, and experimentally he discovered the second law of refraction, and the second law of refraction is also known as the Snell's law. S-N-E-L-L'-S, Snell's law. The second law is also known as the Snell's law. And this constant is known as refractive index. This constant is known as the refractive index, and it is denoted by a symbol mu. We call it as NEW mu. Okay, this is the sign of refractive index. Refractive index. This constant is known as the refractive index. Is it clear? So the second law is also known as the Snell's law. It was discovered by Willibald Snell in 1621. Experimentally he discovered that, and according to the second law of refraction, the ratio of the sign of angle of incidence to the sign of angle of refraction is constant for a period of media. Okay, so the first law states that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same thing. So this first law is same as that of the first law of reflection. In the first law of reflection also, it states that the incident ray, the refracted ray, at the point of incidence all lie at the same thing. Okay, the first law of refraction also follows the first law of reflection. But the second law is quite different here. So the second law is the sine I is the angle of incidence, sine I divided by sine R equals to constant, and this constant is known as the refractive index, denoted by symbol mu. Okay, so in the next class we will come to the term refractive index. Thank you.